All right, so yeah, we're taking a look at solving equations using exponents. And so remember, roots and powers are both exponents. Um, so as we saw already, whenever we have x squared equal to a number or x cubed equal to a number, we can take the respective root in order to solve the equation. So let's look at if it's going the other way, though. If instead we start off with a square root or cube root, and we need to solve for the unknown. Let's start off with the square root of x equals 16. Well, how do you undo a square? Well, we saw that the inverse operation of squaring something was a square root, so shouldn't it be the same the other way? Yes, it should in this case. So that's what we're going to do. We're going to square both sides. So in other words, I'm going to multiply both sides by itself. Okay? And so when I do that, the square root will be undone by the square, and so we'll be left with just x. And then we have 16 squared, which will be 256. Okay, cool. And we're done with that one. That was quite simple. That was easy and fast. But wait, didn't before there was like a plus or minus thing going on? Yeah, that was when we were taking the square root of something squared, an unknown squared. In this case, it says that the square root of x was positive. There was no plus or minus here, it was positive. And anyway, whenever you square a number, you get a positive answer. If you take a number times itself, you get a positive answer. So, in this case, there we go. 256. Okay. Well, what if we look at that in terms of fractional exponents? So, go back up here. So instead of looking at it the way we just did, we're going to look at it as a fractional exponent. So the square root of x is the same as having x to the 1/2 power. Okay, cool. Well, how would I get rid of a 1/2? How do I get rid of half? How would I make that a whole? Oh, and multiply it times 2. So this will be x to the 2 halves. And we'll multiply this exponent up here by 2 as well. So it's squared. Oh, that looks kind of like what we just had, right? So 2 over 2 will give us 1. So we have x to the first power equals 16 squared, which we already said is 256 or 256. So either way, we get 256. If we look at the square root as a fractional exponent and then make the fraction into a whole number, doing and whatever we do on one side of the equation, we do on the other. Or if we just square both sides, they both work. All right, great. That was simple enough. What about when we look at a cube root? Let's see what happens. Okay. So we have the cube root of x equals 3. Well, let's look at it in terms of getting rid of the cube root by doing inverse operation, which would be cubing it or raising it to the third power. So I'm going to take the cube root of x and I'm going to raise it to the third power. And I'm going to do the same thing with the 3 here. So we're going to raise it to the third power. Okay. So in this instance, then, the cube root of x raised to the third power, the cube root in the cube would go away, and we'll be left with x. And 3 to the third power will be 3 times 3 times 3, which will give us 27. Okay, cool. So the cube root of x equals 3. To undo the cube root, we raise it to the third power. Just like to undo the square root, we raise it to the second power. To undo a fourth root, if you did one of those, you would raise it to the fourth power. To undo a 87th root, you would raise it to the 87th power. Okay, and whatever you do to one side of the equation, you need to do to the other because it has to remain balanced. All right. Okay, cool. Nice and simple. Let's look at it using fractional exponents. Now again, if you don't understand that or you just don't like it, you don't have to use it. You can use the method I just showed you there. Okay? And if you need another method, let me know so I can give it to you. Or come up with something, Come up with something together and share it with others. All right, so looking at it as a fractional exponent, the cube root of x is actually just x to the 1/3 power. Okay. Well, how do I get rid of a 1/3? How do I make that into a whole number? Oh, it multiplies times 3. That's right. So this would be x to the 3/3. And whatever I do on one side, I have to do to the other. So this 3 will also have to be multiplied in the exponent by 3. So this becomes a 3 to the third. 3 over 3 is 1, so we end up with just x to the first power. And 3 to the third power gives us 27. Whoa, they both work the same. Well, yeah, we already talked about why that happens the way it does. So, as you see, we can change these to fractional exponents to make it a different way for us to see that the square root or the cube root goes away by raising it to a power. Or you can just take my word for it, it doesn't do it that way. Either way, as long as you understand that to get rid of a square root, you must square the problem. To get rid of a square, you must take the square root. To get rid of a cube root, you must cube the problem. To get rid of a cube, you must take the cube root. The roots and the exponents are inverse operations of each other, but they're still doing the same thing. As multiplication was the inverse of division, they're doing the same. Addition is the inverse of subtraction, they're doing the same. So anyway, inverse operations are awesome to work with to undo one another. And it's a very important rule to remember because we're going to see some other functions that have inverse operations in order to get rid of them. But it won't be operations that you're functional operators that you're used to doing. If I make up something and I say this is the inverse of it, you can always undo it using it. If I say flarpa of 2 equals caca, then to find out that I had 2, I would say caca and do the inverse of flarpa. I just totally made those words up. But I can make up any operator I want with any kind of crazy symbol and tell you something like that. I'm not going to do that to you. But if something like that ever happened, or if you ran into a new type of operation or function operator, you can always do the inverse operation of it in order to undo it, in order to solve. So this is as complex as it gets with these 1 steps. I will see you soon.